Hello everyone, my name is Mr. Zabron Ernest. I teach mathematics. Today I will be helping my students of class 6, of course, revise with them for the upcoming maths exam. I know some students might have lost some notebooks, and I know some students were struggling while taking notes in the classroom. So to help them, I'm going to discuss with all of my students of class 6 with regards to all the worksheets which we gave them. I know some might have misplaced the worksheets, so I'm going to help them remember and try to revise with them some concepts on the worksheets. So to start with, I'm going to start with worksheet number 1, which is all about patterns in mathematics. Then I will move on, all right? So I know the videos will be very long, so make sure that you stay calm, be confident, and be strong so that you watch all of them. So let us start. Chapter number 1 and worksheet number 1, patterns in mathematics. Question number 1. Polygons which have 8 sides are called, we have options here. Option A, hexagon. Option 2, heptagon. Option 3, nonagon. And option 4, octagon. Now, when we name polygons, we have these key words. Hex, the way how it sounds, hex, it means 6 sides. Hept, it means 7 sides. Non, it means 9 sides. And lastly, oct means 8 sides. So, polygons which have 8 sides are called octagon. So the correct answer here is option D. So you're going to write option D, D in capital letters, and then you write the sentence octagon. Right? Next question. What would you call the following sequence of numbers? 1, 7, 19, 37, 61. These numbers are known as hexagonal numbers. These numbers are known as hexagonal numbers. In some later questions, we are going to see why are they called hexagonal numbers, okay? But for now, the correct option here is option B. So you write the correct option here, B in capital letter, and then you write the sentence of it, hexagonal numbers. So let me adjust a few things here. So that is hexagonal numbers. The letter for the options should be capital letter. And then you write the sentence which define that answer. So 1, 7, 19, 37, 61, those are hexagonal numbers. Question number 3. Determine the missing value in the given sequence. Determine the missing value in the given sequence. We have 0, we have 1, we have 1, we have 2, we have 3, we have 5, we have the missing number, then 13, 21, and then we have the missing number. So if you study this sequence, from 0 to 1 is like 0 to 1 is like they're taking 0 plus 1. Okay? So 0 plus 1, 0 plus 1, you get the next number 1. To get the next number, which is 2, you take 1 plus 1, 2. To get the next number, you do 1 plus 2. This is 1 plus 2. Let me write it clearly. So to get the next number, which is 3, you do 1 plus 2, which is 3. To get the next number, which is 5, you do 2 plus 3, 5. So to get the next number, you're going to do 3 plus 5, and you get 8. To get the next number, which is 13, do 5 plus 8, which is 13. To get the next number, do 8 plus 13, 21. To get the next number, you do 13 plus 21. So 13 plus 21, that is 4. 1 plus 2, that is 3. So the missing numbers here are 8, 34, which is option C. So you write here, option C in capital letters, and then you write the sentence, 8, 34. That's the correct option. All right? The next question. Which of the following is both a square number, and a triangular number? Now, let us try to remember. You have to recall what are the triangular numbers and what are the square numbers. Some other people call square numbers as squares. Now, for triangular numbers, what are the triangular numbers? Triangular numbers are 1, 3, 6, 10, 15, 21, 28, and so on. And you have to memorize all of them. Now, how do we move from one triangular number to the other? That is what I want you people to pay attention. From 1 to 3, add 2. 3 to 6, add 3. 6 to 10, add 4. 10 to 15, add 5. 15 to 21, add 6. 21 to 28, add 7. So can you see the pattern? Plus 2, plus 4, plus 6. Down, plus 3, plus 5, plus 7. So it's like up, even numbers, 2, 4, 6. Down, 3, 5, 7. Now, to move from 28 to the next number, everybody pay attention. So that is plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus, guess what? I'm going to write plus 8. 28 plus 8 is 36. To move to the next number, for example, this was plus 8, and there you go down. 3, 5, 7, so you're going to do plus 9. So, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9. So 36 plus 9, you're going to do, this is 14. 6 plus 9, sorry. So you have plus 9 here, and then 6 plus 9, 15, and then carry 1, that will be 45. So those are triangular numbers. Now, these triangular numbers, if you look at them, you can see a plus 2, a plus 3, a plus 4, plus 5, plus 6, plus 7, plus 8, 36. Now this is 3, 5, 7, 9. If you take 36 plus 9, that gives you 45. Okay? Now, if you keep going to get the next number, that was plus 8. So what do you get? So you can try to figure out here. So this is how to develop triangular numbers. Now, which of the following is both a square number and triangular number? Look, 1 is both a triangular number and a square number, but it's not in the options. What is? 36. 36 is both a triangular number and a square number. So the correct option here will be capital letter D, meaning option D, and then you write the number for it. 36. This is the correct answer. Okay? So that is how you develop the so-called triangular numbers. Now, these square numbers, I will talk about square numbers later. But as for now, square numbers are 1, 4, 9, 16, 25, 36, 49, and so on. I will talk about square numbers later. Even triangular numbers, I'm going to talk about the triangular numbers later. But for the sake of this question, which says, which of the following is both a square number and a triangular number? 36 is a correct answer. And this is the way how we write the option. All right? Now, that is question number 4. Next question, number 5. What is the fifth term of the cube numbers sequence? Now, pay attention here. What is the fifth term? What is the fifth term of the cube numbers sequence? The first cube number is 1. Second cube number is 8. Third cube number is 27. Fourth cube number is 64. Fifth cube number is 125. But my concern is, how do we get the first cube number? I repeat, how do we get the first cube number? Everybody pay attention. The first cube number, the first cube number, the first cube number, which is 1, you do 1 into 1 into 1. The answer here is 1. How do we get the second cube number? You do 2 into 2 into 2. What is 2 into 2 into 2? That is 8. How do we get the third cube number? You do 3 into 3 into 3. That makes 27. How do we get the fourth cube number? You do 4 into 4 into 4. This gives you 64. To get the fifth, which is the target, to get the fifth cube number, simply do 5 into 5 into 5. Work out this. You get 125, which is option A. So here you write, the correct answer is capital letter A, option A, and you write the number in front. That is how to answer a multiple choice question. So option A, you write option A in capital letter, and then 125, the sentence in front of it. So this is how to get cube numbers. I will tell you later why do we call these numbers 1, 8, 27, 64, 125. Why do we call them cube numbers? I will tell you the reason later. Question number 6. Which of these is a power of 2 sequence? Power of 2 number sequence. Everybody pay attention here. Power of 2 number sequence. Look, when we say power of 2, are all numbers that have the base of 2, the base of 2, the base of 2, the base of 2, and so on. Meaning, to get the first power of 2, just make it to the power of 0. This is the first term. The first term in the powers of 2 number sequence. And I will tell you what does 2 power 0 mean. To get the next term, or to get the next number for the powers of 2. This was 2 power 0. The next one will be 2 power 1. This will be 2 power 2. This will be 2 power 3. This will be 2 power 4. This will be 2 power 5. And so on to infinity. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Now, the first term, like as I said, in powers of 2 is 2 power 0. Any number to the power of 0 equals 1. So the first term here in powers of 2 is 1. 2 power 1. Any number to the power of 1 equals that number. So 2 power 1 is 2. 2 power 2, this is the same as 2 into 2, and this gives you 4. So powers of 2 are 1, 2, 4, keep going. 2 power 3 is 2 into 2 into 2. This makes 8. Keep going. The next one will be 2 power 4. 2 into 2 into 2 into 2. 4 times. So this is 4, 4, 16. The next power of 2 will be 2 power 5, which is 2 into 2 into 2 into 2. How many times? 1, 2, 3, 4 into 2, 5 times. And the answer becomes 2 into 2, 4. Into 2, 8. Into 2, 16. Into 2, 16 into 2, 32. Now, these numbers you see, 1, 2, 4, 8, 16, 32, and so on. These are what we call powers of 2 number sequence. So these are known as powers of 2 number sequence. So when they ask you, what is the first number? What is the first term in the powers of 2 number sequence? The first term is 1, second term is 2, 4, 8, 16, 32, and so on. They may ask you, so we have seen that the powers of 2 will be this option here, which we have seen. 1, 2, 4, 8. 1, 2, 4, 8, and so on. Those are powers of 2. What are these numbers? What are these numbers? Look at these numbers. 1, 3, 9, 27. What are those numbers? Those are powers of 3. Let us try to see. Powers of 3 number sequence. Powers of 3 number sequence, the same thing. The powers of 3 number sequence, that means they have base of 3, 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 and so on and so forth. Meaning, to get the first number in powers of 3, do 3 power 0. Get the next or the second number, 3 power 1. Get the third, so you keep going. 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 power 4, 3 power 5, 3 power 6. And then you evaluate this. Any number power 0 is 1. Any number to the power of 1 is the number itself. Now 3 power 2, this you need to evaluate. 3 into 3, that is what it means by 3 power 2. 3 into 3, that is 9. 3 power 3, 3 to the power of 3 means 3 into 3 into 3. Work out this, 27. 3 to the power of 4, it means 3 into 3 into 3 into 3. 4 times. 3 into 3, 9. 3 into 3, 9. 9 into 9, 81. To get the next powers of 3, you do the same thing. 3 power 5 means 3 into 3 into 3 into 3, 1, 2, 3, 4. One more. And then you calculate this, you get the answer. So, how do we call these? How do we call these numbers? How do we call these numbers? 1, 3, 9, 27, 81. These are powers of 3. These are powers of 3 number sequence. Powers of 3 number sequence. And you have to know how to get these 1, 3, 9, 27, 81, and so on. Because they can ask you, write the first 6, or write the first 1, 2, 3, 4, 5. Write the first 5 numbers of powers of 3 number sequence. So you have to know. The first 5 are 1, 3, 9, 27, 81. So, which of these is a power of 2 number sequence? Is option A, 1, 2, 4, 8. These 1, 3, 9, 27, these ones here, 1, 3, 9, 27, and so on, those are powers of 3. And how about these? These are square numbers, which I will talk about later. How about these ones? This is just a sequence which has been obtained by from 2 to 6, multiply by 3. From 6 to 8, multiply by 3. From 18 to 54, multiply by 3. This is just a sequence. But this one is a sequence of square numbers. This is a sequence of powers of 3, and this is a sequence of powers of 2. So which of these is a power of 2 sequence? So the correct answer is option A. The correct answer is option A with numbers 1, 2, 4, 8. So those are powers of 2. 1, 2, 4, 8. 1, 2, 4, 8. So the correct option is option A with numbers 1, 2, 4, 8. So you write the option as capital letter, and then you put the numbers in front of that, which is 1, 2, 4, 8, and this is the correct option. All right? So the video will be very long because I'm explaining a lot of things on how to answer a question. So question number 6 done. Then we go to question number 7. Now, what happens when you multiply the triangular numbers? Okay. Listen carefully. Listen carefully. What happens when you multiply the triangular numbers by 6 and add 1? Which sequence do you get? Now, let me see if I have explained about triangular numbers before. Now, just quickly, let me see. Did I talk about triangular numbers? I think no. Triangular numbers, I did not talk about that. And okay, and this one here. Yes, I talked about triangular numbers, but then let me talk it in more details. 1, 3, 6, 10, 15, 21. Let me talk it in more details. What are triangular numbers? Okay, so yes, there we go. What happens when you multiply the triangular numbers by 6 and 1 and add 1? Which sequence do you get? And they can ask you, can you use or can you explain these steps of multiplying the triangular number by 6 and add 1? Which sequence do you get? And can you use a picture or can you use a pictorial representation? I repeat. What happens when you multiply the triangular numbers by 6 and add 1? That's the first question. Which sequence do you get? Can you explain this by using a picture? Or can you explain this by using pictorial representation? So we are going to discuss about all those. Now, what happens when you multiply the triangular numbers by 6 and add 1? First of all, you have to know what are the triangular numbers. These are triangular numbers. 1, 3, 6, 10, 15, 21, 28. These are triangular numbers. And they keep going to infinity. You have to memorize what are the triangular numbers, which from one number is add 2, add 3, add 4, add 5, add 6, add 7, add 8, you're going to get 36, add 9, you're going to get 36 plus 9, you're going to get 45. Keep adding, all right? Now, what happens when you multiply the triangular number by 6 and add 1? You need to do calculation. What happens? The first triangular number is 1. If you multiply 1 by 6 and then add 1, which number do you get? Both must multiply first before you add. 1 into 6, 6 plus 1, 7. The second triangular number is 3. Multiply by 6. Add 1. Which number do you get? 3 into 6, 18. Plus 1, 19. To get the next number, the next triangular number is 6. Multiply by 6. Add 1. What number do you get? 36. 6 into 6, 36. Plus 1, 37. Can you see? Can you see these numbers? Can you see these numbers? What are they? We have seen them. These are hexagonal numbers. Hexagonal numbers. These are hexagonal numbers. Let me carry on. To get this next one, take 10 into 6, add 1. What do you get? 10 into 6, 60, plus 1, 61. You see? 7, 19, 37, 61. These are hexagonal numbers starting with a 7. Keep going. Maybe to get the next one, take 15, because this is 1, 3, 6, 10. 1, 3, 6, 10. These are triangular numbers. These are triangular numbers. 1, 3, 6, 10, 15. Into 6, add 1. What do you get? 15 into 6, 90. Add 1, 91. What are these? 7, 19, 37, 61, 91. These are hexagonal numbers starting with 7. So you keep going. And also the numbers here will keep going. See that? Now, what are these numbers? These numbers are known as hexagonal numbers. Let me try to bring them down. These ones. These are hexagonal numbers. And they keep going. So, ideally, when you take triangular numbers, then for each triangular number, multiply by 6 and then add 1. You get a new sequence, which we call it a sequence of hexagonal numbers. So the correct option here will be option C. Option C. In front of that option, you write the sentence for it, which is hexagonal numbers. Option C, hexagonal numbers. Hexagonal numbers. Now, can you explain this? What is that? Multiply a triangular number by 6 and add 1. Can you explain how we get hexagonal numbers? Well, everybody pay attention here. How do you explain this using a pictorial representation? Pictorial representation. I repeat. How do you explain that when you multiply a triangular number by 6, add 1, you get hexagonal numbers? How do you explain it by using a picture or pictorial representation? Everybody pay attention. Step number 1, because we already know that when you multiply a triangular number by 6 and you add 1, you get a hexagonal number. So what you do is start drawing the hexagonal numbers, or start drawing the pictures for hexagons. I will explain how to do that. So let us see. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, this is the shape. So the first one, you take a scale and draw a hexagon. A hexagon is a regular polygon which has 6 sides. Let us see. 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5, 6 sides. That is a hexagon. So you draw a hexagon. This time, start drawing a small hexagon. And on this small hexagon, indicate dots. The first dot, 1, 2, 3, 4, 5, 6. And you add 1 dot at the center. How many dots do you have in total? 1, 2, 3, 4, 5, 6. Add 1 at the center, you get 7, which is the first hexagonal number. When you multiply a triangular number by 6, add 1, you get 7, and 7 is a hexagonal number. Now, after doing so, you move to the next part. The next part is again draw a hexagon. So you draw a hexagon again. This time you're gonna draw 2 of them. One like previous, but then secondly you're gonna draw another hexagon. 1, 2, 3, 4. No, that's not. 1, 2, 3, 4, 5, 6. Okay, that's good. Now, this time you're gonna draw the same hexagon like before, but this time you're gonna draw 2 of them. One being small, like this previous. Okay. Then later you draw another one which is a bit bigger than that. Bigger than that. Like this one here. And then put this one outside like this. Okay. I hope you people are doing art so you know how to draw. Now, let us see what will happen. Let us see what will happen. The first one, let us count. We have how many dots? Put them here. 1, 2, 3, 4, 5, 6. Put 1 dot at the center. You have total of 7 dots like before. Now, to go to the next hexagon, which is outside, well, at this corner, you keep 1 dot at the corner, 1 dot at the corner. Once you finish putting 1 dot at the corner, then you do 1 dot at the middle of each side. At the middle, halfway. You do it at the middle. Like this dot is here, this dot here, and you put another one exactly at the middle. This is 1 dot, this is another. Exactly in the middle, you keep another dot. This dot and this dot, exactly in the middle. This dot and this dot, exactly in the middle. This dot and this dot, exactly in the middle. This dot and this dot, exactly in the middle. How many dots do you have? You must get a second hexagonal number, which is 19. If you start with 7, 7 was the first hexagonal number. When you multiply a triangular number by 6, add 1, you get 7, which is the hexagonal number. Now, just see. Do you have 19 dots? You can help me count this. But before we had 7 dots. So 1, 2, 3, 4, 5, 6. That was 7 dots. Then we have made more dots. Let us count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is 12 plus 7? You have 19 dots. So 7, hexagonal number. 19, hexagonal number. Let me draw another one. Then you will help me draw the next. Now, to draw the next one, we do the same thing. You draw a hexagon like this. That is the hexagon. This time we're gonna make 2 more hexagons outside like this. Let me get 2. One will be looking like this, and another one will be looking like this. Okay, I will arrange them, don't worry. I will arrange them. So this, you draw a bigger one outside like that, and this time you draw this one a bit bigger. Have space. Give the hexagons space. Okay? Remember here we had 7 dots, meaning 7 hexagonal number, 19 hexagonal number. When you move to the next, let us see. Are we going to get 37? When you multiply a triangular number by 6, add 1, you get 37. Are we going to get a 37? Let us see. We start from the inside hexagon, where we keep 1 dot here, another 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 dot here. Okay? Then remember to keep 1 more dot at the center, because the instruction says multiply a triangular number by 6 and then add 1. So the 1 dot, we add it at the center. So do you have 7 dots? Yes, we do. 1, 2, 3, 4, 5, 6 plus 1, 7 dots. Now going outside, you're gonna make the same thing. 1, 2, 3, 4, 5, 6. Can you see that? So you have kept a dot corner to corner. But what did I say? You keep another dot, 1 dot here, 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 1 dot here. You see that? Now, the great puzzle. I want you to pause this video and think. The first hexagon inside, we kept 1 dot, corner to corner. The next hexagon outside, we kept 1 dot, 1 dot, 1 dot, 1 dot, 1 dot, corner to corner, but 1 more dot in the middle. Guess what? Outside. Next hexagon, you do the same thing. Corner to corner, 1 dot, corner to corner, 1 dot, corner to corner, 1 dot. Now, in the middle, who can tell me how many dots you will keep? Can you think? You will keep 2 dots exactly in the middle, 2 dots. Okay. The first dot, keep it here. And the 1 dot, keep it here. You see, I have 2 dots in the middle. Another one, keep it here. Another one, keep it here. Okay, you have 2 more dots in the middle. 2 dots in the middle. 1, 2 dots in the middle. 2. 2 dots in the middle. 1, 2 dots in the middle. 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 Now, try counting the dots. Are you going to have 37, which was obtained by taking 6 as a triangular number, multiply by 6, add 1. Will you get 37? Pause this video and try to count. Okay? But if you remember, these two hexagon or this structure had 19. Okay? Hello? So this structure had 19. Now let us count the outside shell. 1. Let us count the dots. 1, 2, 1. This is 1, 2, 3, 4, 5, 6, 7. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you have 18 dots. Add 19. What do you have? 17. Carry 1. 1 plus 1, 2. 2 plus 1, 3. 37. So 37. What did we get here? 37. So this is how, if they ask you, can you explain using a pictorial representation that when you multiply a triangular number by 6 and add 1, you get hexagonal numbers. Can you explain using a picture? This is how your picture will look like. Okay? Now, you can see that these are the hexagonal numbers. All right? So now, let us stop here. You keep going. You can try. You can try to figure out what will be the next hexagonal numbers. Okay? You can think, but you're going to make one hexagon, another one outside, another one outside. How many? Now, think about that and let me know in the comments below. For now, let me stop here. I'll come back to the next part of the video. All right? Bye-bye for now.